Hello everyone, I am Dr. Fawzul Atik. I am giving some series of lecture for the course Discrete Mathematics. So we are in the end of this course. The last unit I am going to teach you. The last unit name is Graph Theory unit, the Introduction to Graph Theory. So without wasting time, let us start that. Now, what do you mean by graph? A graph G equal to VE, right? G equal to VE consists of a non-empty set V of vertices or nodes and non-empty set E of edges, set of edges. So this set E can be not empty, but V is non-empty. Then each edge has either one or two vertices associated with it called the endpoints of it. An edge is called, it's said to connect its endpoint. So basically a graph is what? It is like some vertices will be there like this, some vertices will be there and some edges will be there like this, like this. So connecting two vertices like this, the edges are there. So the vertex set may be 1, 2, 3 and 4. This is the vertex set is 1, 2, 3, 4 this set, and it's there are three edges in it, 1, 2 and 3. There are three edges, so edge set is containing three number of edges, right? So these are called vertices, these are called edges. Now what do you mean by finite and infinite graph? A graph with a finite vertex set and a finite edges are called a finite graph. A graph with finite vertex and finite edges are called a finite graph. Like this graph is an example of a finite graph. Otherwise, it is called an infinite graph. So in a graph, if you have infinite number of vertices or infinite number of edges, you call the graph is an infinite graph. So mostly in this, like in this course, we will be considering only the finite graph. Now simple graph. A graph in which each edge connect two different vertices and where no two edges connect the same pair of vertices are called simple graph. So suppose in a graph, if you should have that each edge connect to different vertices like this, where no two edges connect the same pair of, even this one is there, na? But some edges are there, we'll see later on that it is connecting the same edges, like same vertex. This edge will come start from here and come back to the same vertex. This is not allowed in case of a simple graph. This is not allowed. And also you should not have no edges connect the same pair. So here I have a pair of vertices, so another edge I have that which is connect the same pair. That is also not allowed in case of a simple graph. These are not allowed, right? So these things are not allowed in case of a simple graph. This is not allowed. Or you are connecting the same, which is not allowed. If a graph is not containing these things, you call it the graph is a simple graph. Like this one, I am drawing a simple graph which is like this, where you can see that nowhere these things are there. Maybe this is a simple graph example where these things is not there, this is also not there. So this is an example of a simple graph. Clear? Okay, next. Graph that have more than one edges connecting the same pair of vertices are called multiple edges. Multi-graph, and such kind of edges are called multi-graphs, are called the multiple edges. So multiple edges is what? Like this. Multiple edges are like this. So the edges which are connecting the same pair of vertices. This is called a multiple edges. So there are three vertices, there are three edges. There are four edges which are connecting the same pair of vertices. These are called multiple edges. A graph contain this kind of edges are called a multi-graph. Right? A graph that contain multiple edges are called multi-graph. Now I'm giving an example, maybe. So in the similar kind of thing, and I have these two vertices, and from here to here, maybe from here to here you have multiple edges. From here to here you have multiple edges. From here to here you have multiple edges. So this is an example of a multi-graph. This is an example of a multi-graph, right? So I have some edges are simple edges and some edges are multiple edges. So this is an example of a multi-graph, and these are the multiple edges. These are multiple edges. These are multiple edges. Clear? Okay, next. Pseudograph. Some graph include edges that connect a vertex to itself, like connect the vertex to itself, like a loop. Such edges are called a loop. Yes, it looks like a loop. So this kind of edges you called it as a loop. And sometimes we may even have more than one loop at a vertex. Yes, sometimes it is possible that in single vertex you may have another loop, multiple loop. Graph that may include loops and possibly multiple edges are called pseudograph. So now pseudograph means what? Which is not a simple graph, definitely, because it is allowing you to multiple edges. It is allowing the multiple edges, and it is allowing the loop. In this case, it is loop. You may have in another loop here. You may have multiple loop here. So a graph of this kind is called a pseudograph, right? Or which include this. So this is an example because it has multiple edges, it has multiple loops, it has loop. So this is an example of a pseudograph, which is not a simple graph. I hope this is clear. And directed graph means what? A directed graph or digraph VE consists of a non-empty set of vertices V and a set of directed edges or R in E. The directed edges associated with the order pair UV is said to start at U and end at V. So in till now with the graph we discuss all were undirected because there is no direction involved in it. But a graph where all the edges are some directed thing. Maybe I'm drawing another graph, and where you can see that I'll include the direction for each of the vertices. So this is an example of a graph where each edge has some direction. Till now it was not, but now I'm putting some direction, right? I'm putting some direction in it like this. The vertices are A, B, C, D, E, and F. Now see AB. AB is an edge. So AB is an edge where it is direct, starts from E and ends at V. Right? It starts at U. So this graph is a directed graph where in each edges have some direction. So the edge like A is adjacent to B. Like A with the edge AB, the edge AB starts at A, the edge AB starts at A and ends at B. This is how directed graph is defined. Now simple directed graph, when a directed graph has no loops and has no multiple directed edges are called a simple graph. Like in this case, if you have a directed graph like simply, and you can see that this is a directed graph, this each has, and there is no multiple directed edges, right? Like you, if you have this, then it is not a multiple because it then it is not a simple directed graph because you have a multiple directed edges, because you have a multiple directed edges. This is not an example of a simple directed graph. But if you remove that part, you can say that okay, this is a if you remove that part, now it is a simple directed graph, right? Similarly, if you do not have no loops, directed has no loops and no multiple directed edges, so even this one also not a example of a simple directed graph because of this loop, directed loop I have. Clear? But now it is a simple directed graph. Okay, directed multigraph. Directed graph that may have multiple directed edges from a vertex to a second, possibly the same vertex, are called directed multigraph. Yes, there, in this case it is there. You can certainly, just a second. You can have multiple edges. Maybe I am seeing these things, this graph, where I'll have this, and this, the same way directed, this and this, right? This one and this one, both of them are multiple directed edges, and the loops are there. This is undirected multigraph example of it. I hope this is clear, right? Okay. Then finally, the mixed graph, a graph with both directed and undirected edges is called a mixed graph. So this is in general some situation we may have where directed and undirected both cases are there in a graph. That is called a mixed graph. And that is the most general graph where the multiple edges, loops, everything is are involved, right? So in tabular form, what we have learned, a simple graph in an undirected case, a multiple edges are not allowed, loops are not allowed. In a multi-graph undirected case, multiple edges are allowed but loops are not allowed. Pseudograph undirected case, multiple edges, loops both are allowed. Now simple directed graph, it is a directed edges, multiple edges, loops are not allowed. Directed multigraph, it is directed graph and multiple edges are allowed, loops are also allowed. And mixed graph, it can be directed and undirected, multiple edges are possible, loops are also possible. So mixed graph is the most general one. Okay, next. Two vertices U and V in an undirected graph G are called adjacent or neighbors in G if U and V are endpoint of an edge E of G. Right? So in a graph, I am drawing a graph. Maybe I am drawing a graph here. So maybe of six vertices. I'm drawing a graph. So arbitrarily I'm drawing, nothing I'm maintaining. Just I'm doing it like this. So arbitrarily I have drawn the graph. Okay. And maybe I'm drawing one more edges also like this. So what are all the vertices of it? It can be A, B, C, D, E, F, and G. Then two vertices U and V in an undirected graph are called adjacent or neighbors of G if U and V are endpoints of an edge E. Like these two vertices A and B, these two vertices A and B, they are adjacent. Why? Because there is an edge between them, right? So A and B are adjacent vertices. Similarly, C and D are adjacent. But D and E are not adjacent. D and E are not adjacent vertices. Why? Because there is no edge between them. Clear? Okay, next. The such an edge E is called incident with the vertices. Suppose this is the edge, some edge we have, this is an edge. So this edge is incident on the vertices A and B, right? So this is how we call them. Okay. Now degree of a vertex. The degree of a vertex in an undirected graph is the number of edges incident with it, except that a loop at a vertex contribute twice to the degree of the vertex. That part I will discuss. This part I will discuss after some time, right? But first of all, degree of a vertex in a graph, undirected graph, is the number of edges incident on it. So degree of the vertex denoted by degree V. So I want to check the degree of the vertex A. So degree of the vertex A is what? It is like, now how many number of edges you involve in it? 1, 2, and 3. So degree of the vertex A is 3. Then degree of the vertex B is what? Degree of B, how many edges involved in it? 1, 2, and 3. So 3 edges are involved in it. Degree of C is what? Degree of C is 1 because only one edge is involved in it. Right? Degree of D is 4. 1, 2, 3, and 4, 5. Degree of D is equal to actually 5. Degree of D is equal to 5. Right? So this is how the degree is defined. Now you check that for each edges, we have, it is contributing to, like suppose I have one edge like this. I have one edge like this in this graph A and B. In this graph, what is the degree of A? 1. Degree of B also 1. So one edge is having the capacity of contributing degree 1 to its one end vertex and degree 1 to its another end vertex, right? So each edge is capable of contributing degree 2 to its end vertices, right? Because this, it will contribute degree 1 to this will contribute degree 1 to this one also. Now if I have a loop which is an edge and it's both the end vertices are same, then, but we know that an edge has a capability of contributing degree 1 to its one end vertex, degree 1 to its another. But in this case, it is both the endpoints are same. In this case, both the endpoints are same, right? So because of this edge, the degree, this vertex will get degree 2. Correct? Now come back to the point. Except that a loop at a vertex contribute twice to the degree of the vertex. Right? So now if I am just adding one more loop here for the edge E. Now, what is the degree of E? So the degree of E will become now, so 2 for 1, 2 for this, and because of this loop, it is 2. So 2 plus 2, it is 4. I hope this is clear. Suppose I am adding one more loop here. So what is the degree of F? Degree of F is equal to 1, 2, 3, 4, 5. And I'm adding this one loop and two loop here. What is the degree of G? In this case, degree of G is equal to 1, 2, 3, and two loops are there. So 4 plus 3, it is 7. I hope this is crystal clear to you how to define the degree of a vertex and why, if you have a loop, why it is contributing twice to the degree. Because an edge has the capability of contributing degree 1 to its one n vertex and another to its another n vertex. But if the loop is there, that means both the endpoints are same. So if it is a edge like this, then this edge contribute degree 1 to this, degree 1 to this. But a loop is like this, na? So degree 1 to the same, degree 1 to the same. So the a loop will contribute degree 2 to the same vertex. I hope this is clear. Okay. A vertex of degree 0 is called isolated vertex. So here I do not have, but I am adding one more vertex, which is h. What is the degree of h? Because no edge is incident on it. So degree of h is equal to 0. It is isolated vertex, right? Which is different, right? Which is isolated from all other vertices. So you call it as an isolated vertex. A vertex is pendant if and only if it has degree 1, like the vertex C. It is looks like a pendant only, no? It is looks like a pendant. So the vertex C has degree 1. So the vertex C is called a pendant vertex. So H is a isolated vertex, C is a pendant vertex because it is of degree 1. I hope this is clear. Now I have a very famous theorem called the handshaking theorem. What it says, let G equal to V comma E be an undirected graph with M edges. Undirected graph with m edges. Then 2 into number of edges, 2 into m is equal to sum of the degrees of the vertices. Note that this applies even if the multiple edges and loops are present. Like I'm giving you one example. I'm giving you a small example, maybe 5 vertices graph and added some edges. Now what are the degrees of all the vertices? Right, this vertex maybe I'm writing it as a, b, c, d and e. What is the degree of a? It is 2. Degree of b, it is 3. Degree of c, it is 2. Degree of d, it is 3. And I'm adding one more edges here. Degree of e is what? 1, 2 and 4. Degree of e is 4. Correct? Now if I add all the degrees of the vertices, what will happen? 2 plus 3 plus 2 plus 3 plus 4. What is this value? This value is equal to 6 and 4, 10, 14. This is 14. And what is how many number of edges you have? 1, 2, 3, 4, 5, 6 and 7. Right? So there are 7 edges are there. 1, 2, 3, 4, 5, 6, 7. Now that means m is equal to 7. Number of edges is m is equal to 7, right? And sum of the degrees is 14, which is equal to 2 into m, na? 2 into 7, which is equal to 2 into 7. So therefore, we can have always this is true, that number of edges 2 into number of edges is equal to sum of the degrees of the vertices in the graph. Sum of the degrees of the vertices in the graph. Right? Now, why this will happen always? Because we have seen that if I have one edge, it is contributing what? It is contributing degree 1 to one of its n vertex. It is contributing degree 1 to its another n vertex. Right? Even if you have a loop, it is contributing, the loop is contributing twice to the degree. Right? So loop is contributing twice to the degree. Therefore, how many number of edges you have, if you multiply with 2, and if you add all the degrees of the vertices, if you multiply all the degrees of the vertices, you are getting sum of the degrees is equal to 2 into m. Right? So this, even if you have multiple edges, the same thing will work. So therefore, this is known as the handshaking theorem. Correct? So handshaking theorem says that sum of the degrees of the vertices is equal to 2 into number of edges. Clear? Now I'm giving you an example. I have a graph where the vertices, the degrees of the vertices is 2, 2, 2, 2, 2, and maybe 3, 3. I have a graph whose degrees of the vertices is this one. How many number of edges are there in the graph? So just add all of them. It will become the 2 plus 2 plus. So if I add all of them, I will get 8 plus 6, 14. And because I know that 2 into number of edges is equal to 14, therefore m is equal to 7. So in that graph, there will be 7 number of edges involved in it. How I did it? By using the handshaking theorem. I hope this is clear. Then I have an example. you look at this and tell me the answer of it. How many edges are there in a graph with 10 vertices, each of degree 6? So in a graph you have where 10 vertices are there and each have degree 6. So how many edges will be there? Okay, so if I add all the degrees on the vertices, summation of degree v, where v belongs to the capital V. So degrees of each vertices is what? It is 6, right? Summation of 6. But how many number of vertices you have? There are 10 vertices. So if I add all of them, it is 6 into 10. So 60. And by using handshaking theorem, 2 into number of edges is equal to sum of the degrees. So it is equal to 60. Therefore, what is the value of m? M is equal to 30. So in the graph, there are 30 edges are there. There are 30 edges. Because there are 10 vertices, each of them have degree 6. So if I add all the degrees, it will 10 into 6, it is 60. Then 2 into number of edges is equal to 60, therefore m is equal to 30. So in the graph, I have 30 number of edges. Clear? Okay. One more concept. Suppose I am giving you a graph, maybe I'm giving an example of some degrees. You tell me whether it will form a graph or not. I'm giving 4, 3, 2, 2, 1, 1, 0. Is it possible that it will become a degree of a graph? Now you add up all the degrees. What will happen? So 4 plus 3 plus 2. So 4 plus 3, 7, plus 2, 9, plus 2, 11, 12, 13. So the sum of the degrees is 13. But by handshaking lemma, we know that sum of the degrees equal to 2 into number of edges. So m is equal to what? 13 by 2. Is it possible? So sum of the degrees should be an even number, right? But in this example, it is not an even number. So therefore, this is definitely not an degree, like degrees of some graph. We called it as degree sequence. How I clear it? Because I know by handshaking theorem, sum of the degrees should be an even number. But here, if I add all the degrees, it is giving 13, which is not possible. Therefore, this sequence is not an example of a graph degrees, right? All the content I have taken from this book. And if you like the video, please like it, write a comment on by giving your feedback, and follow it, subscribe it, because this channel contains few more other videos also, other subject, probability and statistics. I know that will be very helpful for you in future, right? Share with your friend. Thank you very much. I'll come up with a new video in the next lecture. Bye bye.